Hi everyone, this video is part of Macquarie University's coding tutorials, and today we'll be discussing and looking at array lists and their memory diagrams. Array lists are a powerful data structure that allow us to store and manipulate a dynamically sized collection of objects, unlike regular arrays which have a fixed size. In order to understand the memory diagrams for array lists, it's important to first understand that when we create an array list, we are creating an object that contains a reference to an array. This array is of a fixed size as normal. Then, when this inner array becomes full after adding some items to the list, a new, larger array is made with all of the values from the old array copied over. This operation occurs when we add an item to the array list and it sees that the array it holds is full. One thing to note is that the array the array list refers to also stores references to the items or objects we have added and not the items themselves. This becomes important to understand when we are working with array lists, especially when it comes to manipulating the objects stored by the array list. We'll see this when we create our own list and look at the corresponding memory diagram. This also applies when we are storing numbers in our array list as we are using wrapper classes such as integer with a capital I. As explained in a previous array list video, this is the object version of int, and you'll find that there are other wrapper classes for the other primitives. These wrapper classes allow us to use array lists with primitive values, as array lists always store items of a class type. This simple array list class is a very basic implementation of an array list, but it illustrates the use of an array as an instance variable. As mentioned in a previous video, you can actually look at the ArrayList source code by looking at the java.util.arraylist file that comes with the JDK. However, it will contain a lot of complex methods and use concepts that we don't cover in this course. For the purpose of this video, understanding the simple ArrayList class will allow us to understand how ArrayLists work in memory. In our simple ArrayList class, we have two class attributes: the array to store our object references and an int size. The size attribute will allow us to keep track of how many objects we've added to our list. This is important as the number of items being stored will often be different to the length of the array. We then have the methods add, get, size, and resize. These provide a way of interacting with the underlying array. The add method adds an element to the end of the list or the first available position in the array. The get method retrieves an item at a specified index. The size method returns a number of elements in the list, and the resize method is used to increase the capacity of the array when it becomes full. Do pause the video and read through the code and have a think about how these methods work, paying particular attention to the size attribute and what it does for us in the add method before moving on. Now we have some code that creates and uses an instance of our simple ArrayList class. We'll use this to understand how it works in the background, remembering that this is a simplified version of the built-in ArrayList class. After this first line, the memory diagram would look like this. A reference variable myList points to an instance of simple ArrayList. Within the simple ArrayList instance, we have an array of length 10 pointed to by the R reference. All of the values within this array are null. We also have the size instance attribute with a starting value of 0. Now if we add the values 10, 70, 20, and 90, the memory diagram is updated. The size attribute of the simple ArrayList instance is now 4, and the array referred to by R now has the values 10, 70, 20, and 90, with the remaining spots as null. When the add method gets called, we expect the size variable to be incremented each time, with the new element added to the array R. If the array is full, then the resize method is called to create a new array with more capacity and the elements from the old array copied over. Now let's try finding the size of our simple array list. We can see the array R is of length 10, but 6 of its indices are null. If we call the size method, should we get 10? Instead, we get the value 4 because the size method returns a size attribute's value, which tells us the number of items added to the simple array list instead of the length of the inner array. If we correctly update size every time we add an item to our list, then size should also tell us the first available index in the inner array. At the moment, the indices 0, 1, 2, and 3 are used, with size having a value of 4. Draw a diagram like this out and trace through the process of adding items to see this work. As you can see, the memory diagram for a simple array list is composed of an int size and a reference to an object array, which points to an array. This array then stores more references to objects that have been added. Array lists are a powerful data structure that allows us to store and manipulate a collection of objects. It's important to understand that the ArrayList itself is an object which contains a reference to an array of other object references. In the next video, we'll take a look at 2D ArrayLists. See you there.